Welcome to the video lecture for CS8591 Computer Networks. I am Dr. K. Balasubhadra, Professor and Head, IT Department. Unit 1 is Introduction and Physical Layer. Let us see the problems in Unit 1. The first problem is a network with the bandwidth of 10 Mbps can pass only an average of 12,000 frames per minute, with each frame carrying an average of 10,000 bits. What is the throughput of this network? We can calculate the throughput as follows. Throughput is equal to 12,000, that is the number of frames per minute, into 10,000 number of bits per frame divided by 60, that is 2 Mbps. So this is almost 1/5 of the bandwidth in this case. The second problem is, what is the propagation time if the distance between the 2 points is 12,000 kilometers? Assume the propagation speed to be 2.4 into 10 power 8 meter per second in cable. So we can calculate the throughput as follows. Propagation time is equal to distance between 2 points divided by propagation speed. The distance between 2 points is 12,000 kilometers. That is 12,000 into 10 power 3 meter. And the propagation speed is given as 2.4 into 10 power 8 meter per second. And the propagation time can be calculated as 12,000 into 1000, that is the distance between 2 points, divided by the propagation speed is 2.4 into 10 power 8, that is 50 milliseconds. Problem is, what are the propagation time and transmission time for a 2.5 kb message? Example, it may be an email message. If the bandwidth of the network is 1 gigabits per second, assume that the distance between the sender and receiver is 12,000 kilometers and that light travels at 2.4 into 10 power 8 meter per second. So we can calculate the throughput as propagation time is equal to distance between 2 points divided by the propagation speed, that we know, right? And the distance between the 2 points is given as 12,000 kilometers, that is 12,000 into 10 power 3 meter, and the propagation speed is 2.4 into 10 power 8 meter per second, and the transmission time for 2.5 kb. So the propagation time is equal to 12,000 into 10 power 3, that is 1000, divided by 2.4 into 10 power 8, that is your propagation speed, right? Distance between the 2 points divided by the propagation speed, 12,000 into 1000 divided by 2.4 into 10 power 8 is equal to 50 milliseconds. The transmission time is equal to, that is our transmission time is given as 2.5 kb. So 2500 bytes, and it is converted into bits, that is divided into 8, divided by, actually the bandwidth of the network is 1 Gbps, so divided by the bandwidth is equal to 10 power 9, right? So 2.5 kb is converted as, the transmission time is equal to the transmission 2500 into 8 divided by 10 power 9 is equal to 0.020 milliseconds. So note this case, because the message is short and the bandwidth is high, the dominant factor is the propagation time, not the transmission time. So the transmission time can be ignored. Last problem, that is problem number 4. What are the propagation time and the transmission time for a 5 MB 5 megabyte message? It may be an image, for example. Now the message is very long, and if the bandwidth of the network is 1 Mbps, now the bandwidth is low and the message is long, right? Assume that the distance between the sender and receiver is 12,000 kilometers and the light travels at 2.4 into 10 power 8 meter per second. So as usual, propagation time is equal to 12,000 into 1000 divided by 2.4 into 10 power 8. The distance divided by the propagation speed, that is 50 milliseconds, and the transmission time is equal to actually 5 megabyte. So it is 5 megabyte 5 divided by 1 Mbps, that is 10 power 6, that is equal to 40 seconds. So here the message is very long and the bandwidth is not very high. So the dominant factor is transmission time, not the propagation time. So here the propagation time can be ignored. Thank you.